So I did just want to look a bit closer at these results for a minute and what they actually mean. So I just wanted to look a little bit closer at these results for a minute and what they actually mean. So I'm going to show you the graphs. I did the graphs in Desmos. So here's sine of sine inverse of x. And we've said sine of sine inverse of x is equal to x when x is between -1 and 1. And that's literally because you can't put any value in there that's bigger than 1 or smaller than -1. This range of the sine curve is from -1 to 1. So asking it to find sine inverse of 2, well, that just doesn't exist. It just doesn't even make sense. So that's what limits that. And we can see it does equal x. The sine and the sine inverse cancel each other out. But it is only defined from -1 to 1. Now, the curve y equals sine inverse of sine x, on the other hand, is actually defined over the entire domain here. Between -pi/2 and pi/2, the equation that you get is y equals x, and that's that section of the graph just in there. So at that point, it equals x. It doesn't mean it doesn't exist in other places. It just doesn't equal x in other places. So this section, for example, that line there, the equation of that line is y equals x minus pi/2. Right? The y-intercept would be down here at -2. Now, I'm just going to draw a sine curve on top of that. Now, if you look at my values here, this is pi, so that's a bit more than 3. So 1 is down here somewhere, -1 is there somewhere. So the sine curve would look something like that. And it would repeat something like that. So if you, for example, put pi/2 into this function, sine of pi/2 gives you 1. Sine inverse of 1 gives you pi/2. Now, that's the same over here. This is 5 pi/2 here. If you put 5 pi/2 into this function, sine of 5 pi/2 is 1. Sine inverse, so this whole thing becomes 1. Sine inverse of 1 gives you pi/2. So where the sine curve equals 1, the sine inverse of 1 is pi/2. And that happens in lots and lots of different places. So you can find a result outside of this domain, but it's just not equal to x outside of the domain. So that's what that means. So it's the same for cos and cos inverse. So cos inverse, we've got the line y equals x just defined between -1 and 1, because you can only put numbers between -1 and 1 in there. Over here, however, you can put in any numbers you want. So again, I'll draw a cosine curve on top of here. So it's something like that. Let's keep it going a bit. So if, for example, you put pi in here, cos of pi is -1. And cos inverse of -1 is pi. So you put pi in, it spits pi out. If you put 3 pi in here, cos of 3 pi is -1. Cos inverse of -1 is pi. So you put in pi or 3 pi, it's going to spit out the answer of pi. If you're between 0 and pi, the answer it spits out will be equal to x. So that's the line y equals x. So I hope that kind of makes sense. It equals x when it's between here and here. It doesn't mean you can't get an answer though. Whereas on this one, you can't get an answer if you're outside that domain. Okay, for tan of tan inverse, that is defined anywhere. You put 10 in here, you can find tan inverse of 10. And then you take tan of that, you'll get 10 spit back out. So you put in 10, you get 10 out. You put in 15, you get 15 out. Now, if you're doing tan inverse first, this is the graph. So between -pi/2 and pi/2, you do get x. You get the line y equals x. But it repeats just like the sine and the cosine curves.